Hello, and welcome to the Boffin Buzz, the podcast for anyone fascinated by farming's future. Hello, everyone, and welcome again to another episode of the Boffin Buzz. As regular listeners of the Boffin Buzz will know, we now have CPD points for the Boffin Buzz that you can claim. So do listen in towards the end of this podcast. We will give you the details of how to claim your CPD points. But I'm delighted to welcome this week Dr. Kerry McDonald-Howard from the UK AgriTech Centre. Hello, Kerry.
Hello, Tom. It's great to be here. Thanks.
Well, it's great that you could join us, Kerry. Now, we're doing an awful lot with the UK AgriTech Centre with some of our Boffin trials we'll be talking about in a bit. But, Kerry, you're an expert in slugs and pests and have a particular passion for sustainable control methods. So they have a degree in zoology from Bangor University and a PhD of improving the efficacy of the parasitic nematode of slugs as a biological control of slugs. From Liverpool, John Moores, and describes themselves as
Malacologist.
A malacologist, a nematologist, a parasitologist, and an entomologist. We need to know a little bit more about that, Kerry. So I'd be really interested to know, how you actually got involved in these slimy pests in the first place.
Oh, well, the long way around is, first of all, I grew up on farm. So I know the troubles that farmers have with trying to control pests and things. And my father was continuously throwing every chemical under the sun at different things. So I know the difficulty with that. From my background, as you read a bit of a profile epic thing there, I did a zoology degree in Bangor University, and when I was doing the zoology degree, I got introduced into the world of parasitology. At first, I was a bit dubious, and then I fell in love with it. It was the most amazing world, looking at how everything is intricately entwined and how different organisms rely on each other, and actually it balances parasitism balances out populations and things. And that's when I also got an internship at Treborth Botanic Gardens. It's part of Bangor University, and I did that through the summertime. And while I was there, they said, go ahead, have your own little project on the side and do some work, what you want to do. So I looked at pest management using biological controls.
I see. So this is, when you say pest management using biological controls, this is basically one bug eating another. Is that right?
So essentially, if you biological control is something that is derived from the natural environment that naturally eats something else, whether it be a parasitic, etc. So a biological control, they often they've been studied and they've been researched a heck, and then they've cultured, and then we actually turn them into a commercial viable product, and they are quite often sold. Hence, one of the nematodes that I use, Phasma rabiditis, and that's what I used in the plot trials at the Treborth Botanic Gardens. This little before I go on about the nematode, I should explain what a nematode is. Nematode is a roundworm. You find them everywhere in the oceans and in water and terrestrial, everywhere. It's a very diverse species. It's tiny little. The nematode I was working with was a tiny 1 millimeter one, and so I did quite a bit of work at Bangor University with these plot trials. And so I went on from there and got really interested, and that's how I fell into a PhD at Liverpool John Moores, where I then went into improving the efficacy of the parasitic nematode Phasma rabiditis hermaphrodita. I'll say it quickly so I can say it quickly.
Let's just have that again. So that
You want me
Latin name again, because there's no way I'm going to pronounce it, Kerry. Can you just repeat that?
So the original nematode I was working with was Phasma rabiditis hermaphrodita, and now I've gone on to working with Phasma rabiditis californica. So it's a little bit. It's turned out during my studies, working with some colleagues, that actually Californica was a little bit more effective and things, and that's what they use in the commercial products now. That species.
Now that sounds as though it's a Californian derivative.
It's still so. It may have that name. However, in any biological control, you have to find them in the local area in order to use commercially, and so that has been isolated and found in the UK. There's a number of other nematodes that we have found in different things, but so from that, I loved how that worked together, and that's where I gained my knowledge and enthusiasm for the love of nematodes, biological controls, and slugs.
Yes. Well, I was going to come on
So,
to slugs. What role do nematodes have in potentially controlling slugs? Then, I mean, what are we talking about here? Could you just sort of talk us through it?
right. So, as a biological control of slugs, this nematode is very specific just to slugs. It doesn't go on to any other creatures,
Right.
and it doesn't infect any other animals. This is how I got the role working with slime is because I've been working with this nematode. It's all about slugs and the control of slugs.
Yeah.
So we wanted someone who knows how to find slugs, because I've done a lot of experiments with the slugs, as well as knows a little bit about the nematode, because we're going to be using that in precision spraying.
Sure.
The nematode itself, it moves through the soil. It finds the slug host. It's attracted by like a chemical response. It follows the slug slime. It smells
Right.
chemical. It attracted to the chemical in the slug slime. I say it hunts them down. They can't move very far, so they have to be applied pretty close to the slug. Hunts the slug down, and then the slug itself. If you have a look at the bits and the bobs of a slug, they've got a slight near the head and the antenna. They've got a slight mound with a little hole in it, and that's called a mantle. And at that point is where the nematodes enter, and then they infect the slug, and the slug actually starts showing feeding inhibition at that point. And then between 14 to 21 days, the slug actually dies. So not only have you got
Right.
a control of slugs, but you've also got the slug stops eating as well. So
I see.
straight away, as soon as it gets ill. So it's a naturally occurring in the soil anyway. We're
Yeah.
just putting more into the areas where there used to be more nematodes before cultivation and all sorts of chemicals have thrown on. So we're just balancing the systems out again. And where we've got a lot more slugs, we're bringing in more nematodes to balance that population and lower the slugs
I
again.
see. Well, let's just drill down into that a little bit more, if we can, Kerry. So
Mm.
let's just talk about the slug for how close to the slug you actually have to get these nematodes in order for it to happen. In practice, what are we talking about there? Is it
Uh,
millimeters, centimeters, within a
so
meter?
again, when we're talking about this kind of application, you've got to think of the co-evolution of a slug and a nematode.
Yeah.
A slug lives in a moist, organic environment. That's where they thrive, and
Yeah.
they're thriving right now,
Yeah. Yeah.
all
I
year
think
long.
so. Absolutely.
And the nematode, like a lot of parasitic and hosts, and their hosts, they often have co-evolution, and they're similar habitats.
Right.
So the nematode will like a more organic environment, a more moist environment. And if you are having to apply the nematodes to the soil, if you applied it to a dry, arid soil where the slugs are deep down because it's sunshine during the day, your nematodes are not going to get anywhere near the soil. The
Well,
slugs,
could we
they
just
won't even find it.
clarify, Kerry, if you apply the nematodes to a dry soil, to that environment you're just talking about, would the nematodes die or would they just go dormant?
If it's very hot and the soil doesn't have any clay or organic matter, the nematodes have got a certain survival time. Because actually, part of my PhD was looking at how long they would survive in different soil types. So I had little
Right.
petri dishes. I'd add some nematodes and count every few days how many were still alive in the different petri dishes. And what we found is that in the really, like the sort of topsoil, the very
Yeah.
grainy, dry sort of one, the nematodes can survive for a little bit of time, but they desiccate quite soon and just disappear.
Right.
But if it's in a cooler environment, so at 5 degrees, those nematodes just last a little bit longer. But then if you're looking at the nematodes then in a more organic soil or a clay-like soil that absorbs the moisture and holds the moisture, those nematodes go further. And again, if the
Right.
temperature is hotter, they survive for less than if it's colder, even if it's not so longer in the clay soil than the topsoil, but longer if it's cooler.
Right.
So
And are they
there are
like
different abiotic and biotic
yeah,
factors you've got to consider when applying them.
yes, exactly. And
Yeah,
we know that with slugs, when it gets dry and when it gets conditions that they don't like, then they go down, burrow
yeah, they have
down.
to go
Do
deep
nematodes
underground.
do the same?
The nematodes, there are some down there.
Right.
But if we want to get the slugs and we want to actually have a precision application, we want to get the slugs when they're on the surface. And
Right.
those nematodes aren't going to be able, the nematodes that are already down there, they're not going to be able to travel up and down the soil,
Right.
columns as you want to call it, up and down the soil. So if you apply the nematodes directly onto the slugs while they're out and about, they will take the nematodes down with them. And not only
Ah,
will they kill that slug, but when the nematode infects and kills the slug, that's the juvenile stage of that nematode. The nematode then reproduces on the dead slug, because
Right.
that's what they feed on, and it repopulates that area all over again with thousands of little nematodes just
I
from
see.
that one nematode entering.
So,
And
so,
the
so the,
hermaphroditic as well, so they just keep on going.
so the more slugs you have, if you apply nematodes to them at the correct time and everything and so on and so forth, the more slugs you have, the more
The more
nematodes you'll
nematodes you
have.
have.
So that it kind of carries on
Yeah.
as the slug control.
But it's
Um,
all about applying correctly and precisely. So
right,
correctly taking those abiotic and biotic factors into consideration when applying, as well as applying when it's cooler, even
right,
at night. And that's what we're talking about with our work and things, in the damper, cooler times,
right. I
and on the
see.
right soils. There's no point in going and throwing it on a field where it's all dry, no slugs are about. You're just wasting your money then.
Yeah, and you
Uh,
said precisely as well. So,
mm,
what sort of if we were to go out and
mm.
actually apply it to the soil with a sprayer or something like that, what sort of area? I mean, presumably we actually have to hit the slug, do we?
Not necessarily. So they
Right.
do move to a certain amount, but they're not going to cross an entire field. I should explain a little bit more about the actual nematodes, and because I'm going a
Yeah,
lot of.
sure.
I think you know quite a bit about nematodes because you've heard me rabbit on a bit about them. But to everybody else, I often get, what is a nematode? So
Yeah,
first of all, they are from the phylum Nematoda, and there's over 1 million species of nematodes. For every 4 to 5 animals, there's there's over 1 million species of animals, and there are over 4 to 5 animals that live on. There's a nematode, so there's just
right,
millions of them. And as I said, they're everywhere, and they suit all different habitats. So they've been able to evolve, and they've been documented, so recorded, fossil records and things, over 400 million years old.
right,
But because, as I say, they dissecate quite easily because they've got bodies with no bones or anything like that, so they just perish, sort of thing. That scientists and researchers actually think they're over a few billion years old.
right.
So, so they're as old as bacteria
I,
and protozoa and fungi, sort of thing.
yeah, I did hear somewhere that in terms of body mass or something, the weight of nematodes
Yeah.
is staggeringly huge. Actually, I can't remember exactly what the figures were, but it's one of those things that you just don't realize just how many nematodes there are out there, I suppose.
Yeah, you just, your mind boggles at the thoughts of the numbers when you
Yeah,
quantify how long they've been here. And even though they are very simple, they have very simple anatomy, they have diversified, and that variation
right,
is uh, amazing. It's all so with the parasitic nematode I work with, it's the adult side is approximately 1 millimeter, and we're looking a bit smaller, so quite microscopic. I generally use a dissecting microscope to look for my nematodes and things. And then when you look on the other side of things, you've got a 8 to 9 meter nematode that generally lives in the placenta of, what is it? And it's called placenta gigantissima. Now I need to ask that expert to pronounce that name, but that's in the sperm whale, the placenta of the sperm whale. So
eight
that's
to
what I
nine
mean.
meters long.
Yeah, so that's what I mean. The
Ah,
variation is amazing. It's just, and the way they are able to live in the different things, it's just incredible.
oh my god!
So
Imagine that having
I
a
know.
oh my god! Oh, the mind bog. Oh
Yeah.
dear. Yeah.
So
So it's a very diverse.
yeah,
Um,
and when you look at nematodes that are associated with slugs and snails, there's already been 108 that are sort of documented and recorded, and then of that, we've been able to isolate 18 different species of phas from slugs that parasitize the slugs.
right.
So, and that's what we've got. So we've played with those, worked out which are faster, more
Yeah.
efficient at killing, which just hang around a little bit longer, which are a bit slower, and things like that. So that's where we've got to Phasmorhabditis californica at the moment.
Right. I see. So, I mean, it
Yeah.
sounds like there's a lot of work that's gone into
Yes, it's good.
using nematodes as a form of slug control. So, how does it stack up against chemical control of slugs? I mean, because I'm familiar with there's a product Nemaslug, I think,
Mm.
isn't there, that
Are we allowed to say that?
gardeners use. So, why are
Yeah.
we not using nematodes in agriculture?
Well, the difficulty is again those abiotic and biotic factors. If you're applying and just the nematodes are dying off and not being used correctly, it's going to be very costly.
Right.
So that's one of the things we're working with right now, working out that precision, working out where we are putting them exactly, so
Yeah.
it knocks down that cost beautifully. With we'll delve into a little bit what we're doing later on, but yeah, no,
How
I've
does it
gone off.
stack up against? I mean, I mean, would it actually be possible to spray a whole field with? No, would I ever want to do that? Well, I mean, I don't know whether it would be cost effective to do that.
I don't think it would be cost effective. You could do that,
Yeah.
and a lot of gardeners buy it right now and put it over their garden. But what we're thinking is, let's take the nematodes straight to the slugs. So the little things don't
Right.
have to move around trying to find them, and that makes it much more cost effective. But you've also got the other side of things. The chemicals have come at a cost themselves.
Mm.
They are toxic to non-target organisms, and they're also really toxic in water. Well, metaldehyde, we formerly used that
Yeah.
before, and now, as you know, that's banned, and I think it's banned since 2021. So we're left with one other chemical control, ferric phosphate, and that's very limited. And the
Mm.
benefit of the nematode is it's not toxic to anything. It only infects slugs, and there's nothing it damages in the environment whatsoever.
Yeah.
So we get the precision down, we get the application to the actual slugs, knock down back the populations. It will be very cost effective, and that's where it comes to using our autonomously systems, monitoring and precision application. I
I
think we should
see.
probably go into.
Yeah. So
Yeah,
I mean, looking at using it in an arable environment,
yeah.
as opposed to applying slug pellets, for example, I'm just trying to think of, what the differences are between these controls. So, I mean, for example, with slug pellets, the thing about slugs
Mm,
is that you need to draw the slug to the pellet.
mm.
This is the whole thing, isn't it? That it's a living pest. You need to draw the slug to the pellet to make it.
But our
Unlike,
nematodes go find the slugs.
sorry.
Our nematodes go find the slugs.
Yeah, well, that's
Yeah,
that's the interesting thing there, I guess, isn't it?
yeah.
That and the other aspect is that the pellets only last for a certain length of time in the soil. Obviously, that depends on conditions and so on.
Mm,
But I guess the conditions that are conducive to nematodes
mm.
are going to
Perfect for
be
slugs.
more conducive to slugs, whereas they're going to be less conducive to pellets, which will
Yeah, so
break down and disintegrate, won't they?
and wash away into the water sources, causing even more havoc.
Yeah.
But yeah, so the nematodes work really well like that. And with the work that we're doing, where we're going to go out and we're going to be able to have a monitor. So I suppose when you look at the chemical controls, from what I know with the farmers at the moment, the management and how to check where the slugs are, we've got the
Mm.
slug shelters on the different patches of the land, and they
Yeah.
check and they're like, right, okay, we've got a heavy load of slug, and then they broadcast spray. Now
Yeah.
that's quite expensive on its own because the farmers don't know where the larger patches of slugs. And slugs are like homing pigeons. They have homing areas. And our other partner who's working on the project with us as well, Professor Keith Welters, he's
Yes.
working on precision location. And that's looking at what type of soil type, where we're finding these slugs. And he has his fun fact where the slug always turns left. And
Yeah.
yes, they're like homing. It's a case of resources. If something wants to survive, they stay close to where the abiotic and biotic factors are correct, so they can survive because they've got moist bodies that need moisture around. They need the food and food sources around them, so they have to stay locally in that. Even if there's wheat a bit further on, they know they'll stay in a moist environment. The wheat's here,
Mm.
let's go wild here. But the farmer will come along and throw, well, not throw, broadcast spray the pellets across, and then you've got loads that's just being washed away and useless because the slugs aren't even there,
Yeah.
or it's so wet that the slugs are having a good old time. I've been out there sometimes. It looks like it's a slug party on the field.
Mm.
I've seen the pellets wash away and the slugs are still there. But
Yeah. But
so
we're
that's where
talking
the nematodes just go straight for the
exactly.
slugs, and
Yeah.
they survive in such an environment.
So can we actually have a situation where let's
Interesting.
take an area of your field, a patch or whatever, where the slugs are getting away, whatever, they're thriving in this patch. If
Yeah,
we go there and we apply nematodes in the right places, will
yeah,
that basically, because they regenerate and because they last for a while in the right conditions and so on,
yes, they
could
can.
that basically be it for the season? That they'll just sit there and they will look after your slug population for you? Could we
They
actually get to that situation?
Oh, that is the dream. We
Yeah.
want to get there. We've got a lot of hard work to do because we've had a good few years of chemicals on the actual fields, and we've got to bring up those populations of the nematodes, and the slug populations have really done well, especially this year with the warm, wet winter we've had, and just now it's just so wet. So yes, there's a bit of work to do, but the idea is that is your best shot. Let's get the precision, get the precision spraying of the nematodes in the right areas. It'll slowly knock you'll see the impacts over the next few years, and it's the way to go.
Great.
And that's where this project's coming into play quite nicely, isn't it?
Well, exactly. So let's move on to slimers. So this is strategies leading to improved management and enhanced resilience against slugs. It's a 3-year project, £2.6 million £DEFRA-funded project. UK AgriTech Centre are one of the partners in this. Now, I'm not going to go into too much detail because we're going to be talking about it in more detail in the next podcast. But just briefly, just to give people a little bit of a taster of the next podcast, Kerry, what made you want to join the Slimers project?
Well, while I was doing my PhD, I was very aware of a project called Slugbot. I think you were involved in it. And that was with Dr. Jenna Ross, OBE. Always got to say the OBE. And so Dr. Jenna Ross, I was following the story of what was happening with Slugbot because I know that she was very involved with different nematode work and things. So I became very aware of all the work, and it looked very exciting that they were using a robot to go out there and build an AI training model set to actually find the slugs and do the spray. So this was the baseline for what Slimers was basically, and it's now worked into a more commercial scales where we're going to, where we can actually take it out to the farms. And it looked very exciting. And now, voila, I'm on this marvelous project. So I've been following the story as we've been going along. And it just seemed like the perfect solution for quite a big problem that we have in the UK right now.
Yeah, well, I've got to agree with you there, Kerry. I have to say, I mean, it was the Slugbot project as well that was one of the inspirations behind the Slimers project. As it
what's
now
led
is.
to it, hasn't it?
So we'll anyway, we're going to leave it on a cliffhanger, Kerry, because we're going to look in more detail at the Slimers project and in particular your work within that in the next episode. But that's all we've got time for at the moment, I'm afraid.
That's good
so
chatting.
Listen, thank you very much, Kerry, for joining us. Don't go away because we're going to talk in the next episode about your work with Slimers. But thank you very much for that introduction. Thank you very much for
Thanks, Tom.
the
Thanks for having
introduction to nematodes. Now, as I said, there are CPD points available for listening to both parts of our podcast with Kerry. So get your pens out. The first code, the first half of the code that you need in order to claim your basis points is C for Charlie, P for Papa, /139458. So that's CP/139458. And we'll come back in the second part to give you the second part of the code that you will need to claim your basis points. So, well, thank you very much, Kerry. As I say, thank you very much for listening, everybody. And we'll join you again on the Boffin Buzz.
Cheers.